Hey, so I finally got around to showing you how to teach elimination versus substitution. So we have substitution versus elimination. So let's just take a problem. Let's make up one. Here's how I make up these kind of problems. I start with the answer. Let's say the answer is x is 2 and y is 3. So, of course, you wouldn't give kids that at the beginning, but this is how teachers make up problems. So you just have to make it true. Something like y equals x plus 1. So see, if you put a 2 there and a 3 there, that's true. So there could be 1, and let's say the other one is 2x plus 3y equals, so that would be 2 times 2 is 4, plus 3 times 3, which is 9. So 4 plus 9 is 13. So let's say those are the two equations. So yeah, substitution. If it's solved for y, you can just take that and stick it in for y. So you have 2x plus 3 times x plus 1. See, now you only have one variable, so okay, 3 times x is 3x. 3 times 1 is 3. Put these two together, so we have 5x. Okay, I'm going to pick up this positive 3 and put it over there as negative 3. So that's how I teach that. I don't put minus 3, minus 3. I teach if it's on one side, it's its inverse on the other side. So there's 10 divided by 5, and x is 2. Check. And then you got to substitute it again. So substitute it back up in there. So now that one is y equals, we know x is 2, and there we have y is 3. Check. So that worked. So that's the substitution method. The problem with substitution is if it's fractions. See, nobody ever gave you a fraction probably when you're doing it. So substitution, you were fine with substitution. Let me just make up another one. I'm just going to make this up now. Let's say we have y equals 2x minus 5 and 2x minus 7y equals 10. My guess is that doesn't work out very well. So here I'm going to take the 2x and stick it in again. So now I have 2x minus 7 times 2x minus 5. Now this is a negative 7. Kids miss that all the time. So negative 7 times 2x is negative 14. And negative 7 times negative 5 is positive 35. You have to emphasize that. You'll be emphasizing that your entire career, that negative 7 and negative 5 is positive 13. Now that's negative 12. I'm going to move the 35 to the other side. So now I have negative 12x and negative 15. So dividing off the negative 12. Now x equals 15 twelfths, which reduces by, what, 3? So 15 divided by 3 is 5 fourths, so it's 5 fourths. See, now you don't have something quite as nice. Now you got to take this 5 fourths and go stick it back up there, and it becomes a fraction problem. So 2, of course you can do it. It's 5 fourths minus 5, so I actually got a pretty clean one. 2 over 1, so that 2 can cancel that 4 down to a 2, so it's 5 halves minus 5 ones, so that's 5 halves minus, multiply that by 2, is 10 halves. So 5 halves minus 10 halves is negative 5 halves. So it's a hassle doing that. Okay, here's what elimination does. Elimination would have worked much better for that one. So when we're doing substitution, see, it's still, the very first step still gets rid of one of the letters. So see, you're trying to get rid of one of the x's or the y's. Elimination does it like this. If you have 2x plus 3y equals 9 and 2x minus 3y equals 4, if you now take this whole group and add up the x's, if I take those and add them together, we get 4x. If we take those and add them together, we get 0. And if we take those and add them together, we get 13. And now we can divide by 4, and x is 13 fourths. Now you do have to go sub it back up in there, but I'm going to show you a different way. But I just wanted to make sure we knew what elimination is doing. Elimination means one of the letters are getting eliminated. So if you don't have that, let's say it's 2x plus 5y equals 10, and maybe 3x minus 4y equals 7, something like that. Okay, you have to force elimination. Now, it doesn't matter which one we force, you just have to force one. So I like to work these sideways, so I'm going to get just a little bit more paper. Let's say I try to make these the same, since one's positive and one's negative. If I multiply this whole thing times 4, see, that's going to make 20. And if I multiply this whole thing times 5, it's going to make that one 20. They'll both be 20. So if I take all of this times 4, so 2x times 4 is 8x. 2x times 5 is positive 10y, and 4 times 10 is 40. See, that's the same equation. It's just been cranked up times 4. I'm going to crank this one up times 5. So that's 15x. 5 times 4 is negative. Oops. 4 times 5 right there should have been 20y. Sorry. And now 5 times 4 here is negative 20y. See, the goal was to get those 20s the same. And now 5 times 7 is 35. Now when we add them up, see, when I added up that 0, it was eliminated. So 8 plus 15 is 23. That's gone. And over here, 40 plus 35 is 75, and we can divide by 23. So the x is 75/23. So that also is not a very nice one. We would have to take that. Sorry. We would have to take that and go sub it back in one of the originals and see what it is. Okay, here's why elimination is really useful. Let's just say we have something like, here's elimination again. Well, let's go do it back on that problem that I had. This one over here, where it ended up with fractions. So we have y equals 2x minus 5, and the other one was 2x minus 7y equals 10. I like elimination a lot, so we'll have to organize it a little bit. This one is good. I'm going to move this one around so that the x and y are on the same side. So I'm going to pick this 2x up and put it over here. So that would make it a minus 2x, and then there would be this y. And then this side would have the negative 5. So I just rewrote it so the negative 2x was over here. I took it from there and put it over here and now stacked it up. Just so happens the x's are already gone. So when I add those up, those add up to 0. Adding these up, it adds up to negative 6y. And adding these up adds up to 5. Divide off the negative 6, divide off the negative 6, and y equals negative 5, 6. That should have been the same answers over here. So I made a mistake on one of them. Let's see. I either made a mistake over here, which is probable, or I made it over here. Oh, I could go back and find it. You probably have already seen it. What did I do here? 2x minus 5, that makes negative 14, positive 35, negative 12. Okay, it was right here. Okay, so the 10 minus 35 was 25. I thought I probably missed it over here. So this is 25, 12, and blah, blah, blah. So this one was actually wrong. It's easier to get it right over here. So the y is actually negative 5, 6, not this one. Okay, but the reason that I think elimination is easier is you don't have to go sub this in and get it. You can just start over. It was negative 2x plus y equals negative 5. That was this one. And the other one was 2x minus 7y equals 10. You can just do elimination again for the other one. So we found, so this one we made the x disappear. Let's just crank it up so the y disappears. I'm going to multiply all this times negative 7. So negative 7 times 2 is now 14x. Negative 7 times y, oh, I need it positive 7. So positive 7 times negative 2 is negative 14. 7 times y is positive 7y. And 7 times negative 5 is negative 35. And see, now that eliminates the y, and it'll just give us the x answer. See, here's negative 12x. Here's negative 25. Divide off the negative 12. So there it is. X is negative positive 25/12, just like it was over there, what it was supposed to be over there. So see, we never had to substitute in any negatives. We never actually had to work with negatives, I mean fractions. We did actually never had to work with fractions, even when the answers were fractions. Let me show you just one more. Let's say we have something like, I'm just going to make this up so it'll probably be a fraction, 2x plus 7y equals negative 3, and maybe 3x plus 5y equals 4, something like that. Let's say that's the equation. Okay, well, one of the things, I'm going to go this way. I'm going to try to eliminate the y's, so I'm going to make those up to 35. So I'll multiply this one times 5. Okay, 5 times 2, that's 10x. 5 times 7, that's 35y. And 5 times negative 3 is negative 15. And then to make that happen, I need to make this one a 35, so I'll multiply these by 7. So 3 times 7, that makes that 21x. 5 times 7, that makes that 35y. And 7 times 4 is 28. Now we need one of these to be negative, so they add up to 0. So I think I'll just go here, make all of those negative. So a negative 15 now makes it positive. So now when I add these together, negative 10 plus 21 is 11x. Add these together, it's 0. And then 15, 28, 38, 43. And then divide off the 11. So the x value is 43 elevenths. Now if we were going with anything and we got this weird answer, we'd have to go substitute it back in, like go stick it right there and see what the y, and then solve it for y. But I'm not even going to use substitution for that. I'm just going to go this way and make the x's eliminate. I'm going to make both of these become 6. So if I multiply this by 3, 3 times 2x is 6x, 3 times 7 is 21y, and 3 times negative 3 is negative 9. And then I'll multiply this set by 2, so 2 times 3x is 6x again, see I got those the same. And 2 times 5 is 10y, and 2 times 4 is 8. And now I need one of these to be negative, so again I'll just make this one negative. I'll multiply all those by negative 1, and I'll see that is 0. Negative 21 plus 10 is negative 11y, and 9 plus 8 is 17. Divide off the negative 11, and we have negative 17 elevenths is the y. So those two things should make both of those true. So we're basically done, but you know, early on you could have kids check that. So if we stick the x value in right there, kids hate checking, but sometimes I make them do it at the very beginning, and then stick the y in there, so 5 times negative 17 elevenths. That should, question mark, equal 4. Well, if you have a calculator, it's not nearly as bad. So 3 times 43 elevenths plus 5 times negative 17 elevenths. Okay, if these solutions are true, it should add up to 4, which it certainly does. So and we could go check it into that one too. If we put it in here and here, it'll add up to negative 3. So that's another reason to use elimination, is because it's actually easier when the problems are harder. Had you done that as substitution, we would have had to solve for one of these. So maybe we move that over there. So it'd be 2x. So it'd be negative 7y minus 3 by moving that negative 7x over there. Dividing everybody by 2. Now you got to go take that and stick it in the other one. So we'd have to take that and stick it there. So it becomes quite a bit more difficult if the original problem is difficult. Whereas elimination, we never really dealt with the fraction until the actual answer. And then over here, we never really dealt with the fraction until the actual answer. So you can put that in your bag of tricks for when you're tutoring elimination. You have a reason now why to do elimination. You could make up problems that are a little bit harder than the kids are given so that it ends up having fractions, and that will drive the point home.